Hey, welcome back. This is Math 0965. We want to do a review for test one. And I sort of want to also go through the kind of testing procedure. So the first thing you're going to do on the day of the test, probably get here like 5 minutes before time. So for our class, right around 10:55, right? Because our class is at 11. So get here around 10:55, and go into your Blackboard, okay, for our course 1965. And then you're going to go over here to the testing tab and click on that. And the test will be here. There's the two documents. If one is easier to download than the other, or you have some requirements that you need. One's just a PDF, the other one's a Word document. So it doesn't really matter. Most people can open the PDF. But you should be in WebEx, and then go to the testing tab and then download your test. So you'll click on this and the test will pop open. So you'll either download it or you'll print it out. Then go back to WebEx when you're ready to begin. So when you're ready to begin, then click on the chat button and message me in chat and tell me you're ready. Okay, so I'm ready to start. And then send that to me and wait. Okay, so don't start taking your test or anything like that yet. Just wait around for me to get to you, because I'll have like 15, 20 students in the class. I need to go to every one of them. And what I'm going to do is check your work area and your papers and your calculator type. Okay, so I'll ask to see your papers. So if you print out the test, I'll also need to see your test papers. So basically, you need to put it up to the webcam so I can read it. I'll need to see front and back, so you don't have it. So I know you don't have any notes. Then after you go through all that, it's going to take some time for me to go around to everybody. So just be patient. Once you get done with that, then show me your calculator. So this calculator is fine. It's scientific. This calculator is not fine. It's a graphing calculator, has that big screen on it. Bad. I will not let you use one of these. Okay, this calculator will do the test for you. Okay, so this is it. This is the guy you got to use, or something similar. Okay, if you're worried, come to my office hours and say, hey, Mr. Stroop, can I use this calculator? And I'll say yes or no. Okay. Okay. So once I've checked you off, I'll give you permission to start. I need to be able to see both your hands at all times. So I have a lot of students that will kind of do one of these jobs, and you can imagine they're sitting there taking their test like this and kind of looking. I can kind of tell if you're cheating or not. No. Okay, don't put anything in your lap. I need to see your hands, so just keep them up. Make sure you're in a kind of comfortable position so you don't have to, if I see a lot of like mousing, like I see you sitting there like this, for a while, no, that's not going to work. Even if you've downloaded the test onto the screen here, you shouldn't be mousing and scrolling all over the place, right? You should, when you're done, you should just be maybe scrolling a little. Maybe you have to go like this to get to the next problem, like this to get the next problem. So I shouldn't see any of that. I shouldn't see any typing. So there's no reason to type unless you're sending a message to me. So no typing. Things I've seen that are bad. So I've seen students like have their books and stuff, and they kind of leaf through them. I could tell. If I suspect you of cheating, I'll just stop you and have you take the test a different day, and you'll be taking a different test. So you're not taking the same test as what the other people in the class will take. You'll take a special one. Okay. So just be aware of that. I reserve that right, and I'm just trying to do my job and keep everybody honest. Honestly, if you cheat through this class, you ain't gonna make it in the next class. So you're just doing yourself a disservice. And okay. So you'll take the test, and then when you're done with the test, you'll message me again and say, hey, I'm done. Hey, I'm done. Can I begin my scanning process? Okay, this tells me that you're going to pull out your cell phone or something and take pictures of your test, or it tells me you got to get up and go to the next room and put your papers in a scanner and then scan everything and upload it. Okay, so as soon as you send that to me, I'll send back, okay, you can start. And that prevents you from making a mistake that I could interpret as cheating, okay? So if you just pick out your cell phone and start going to town, no, that's bad news. You're in real trouble, okay? So you got to tell me, you got to let, hey, Mr. Stroop, I'm going to start my scanning process. Is that okay? And then I'll give you permission, and then you can go ahead and start, okay? Okay, once you're done scanning, then you upload it to your computer. Basically, you could go to Microsoft Word, and then, I put some other links, like a CAM scanner in there you could do, but the easiest way to do it is just to take a picture from your computer, put it into the Word document, and then go and save it. Okay, so I'm going to save as, browse, whatever, put my name on it, Stroop 0965, test 1. And then I'm going to say, look at how I save it. It says save as type. I'm going to go to PDF and then save it. And, I'm going to put it somewhere where, let's put it in the summer, and then put it in there. And it should give me a PDF version of it, which you see right there. And then I can go to my mail and, new message, send it to myself, David Stroop here, attach the document, upload, summer 21, where is it? Stroop 0965 test 1, upload, and it should be there. And this is test 1. And then send it. I'll put it in the subject line, test 1, Stroop 0965, because I have a lot of people, a lot of tests. I need to be able to see who you are in my in my inbox, and then go ahead and send it. Okay. And once you send it, then go back to the chat here and say, okay, I sent it. And then you'll have to wait for me to confirm that I got it in my mailbox. So when I go into my mailbox, then what I'll do is kind of, click on it, open it up, and then go through it and make sure I got all of the pages. So a lot of people accidentally forget to put something in there. I got to make sure I get them all. So there's another category of people that will just kind of accidentally forget to give me a page and then go do the page, and then, So I got to make sure that I get all your pages. And once I go through and make sure I got all your pages, I will say, okay, I got your test. You may leave. Okay. And then at the end of the day, when I'm done grading, I'll go to the Blackboard and return your test via Blackboard. So if I go to my courses here, there's a tab for return tests here, and it's like an email system, and I'll send it to you there. I don't send it through my regular email, because usually my regular email can't handle the load. Okay. Okay, so that's the process. I apologize for it being so annoying. I'm not crazy about it either, but that's the pandemic for you. Okay, so hopefully that alleviates any of your anxiety. And hey, this is what I look like, that sort of thing. Okay. Right, so let me click out of there. I think I want to keep that open just in case somebody emails me. These are technically my office hours. Okay, so right, let's get to the review now. And so the way it kind of works is you're either going to be using your book to review, or you can use my math lab. In particular, for example, in 6.1, so And if somebody wants me to do all my videos in this kind of way with black background but white letters, let me know and I'll do that from now on. But otherwise, I'm going to go back to white background with black letters. Okay. So anyway, 6.1 is on factoring, and the directions for all of these problems will just be to factor. And from the book, you'll be looking at questions similar to this 13 to 85 odd. So there's a lot to pick from. So when you go to practice, and the way it's going to work here, I'll do one question, and then what you're going to do is go to the book or go to My Math Lab and find a similar question and try it on your own. I think that's the best way, and just keep on repeating that process until you're sick to your stomach, right? But anyways, how do I know in the software what problem is similar to number 26? Well, you can go into your assignments, click on 6.1. and just pop up anyone. If you look right here, it says 6.1.27. That's actually problem 27 in the book, okay? So if you're looking for problems to practice, like I say here, 13, look for problems in the range from 13 to 85 odd. So 27 would be in that range, 6.1 number 27 would be in that range, and this would be a good practice problem, okay? So obviously, when you do the test, it's going to be you're going to be doing your questions and answers. You'll do your answers like I'm going to do them here in the review. But for practice, you kind of, it's easier to go to the book. But if you don't have the book, you can always use the questions in the My Math Lab for practice. Okay. So let's get in here and take a look. And the first kind of problems we were just, even before we dealt with factoring, we were just identifying the greatest common factor. Okay. So the greatest common factor between these two numbers is the thing that we're going to be factoring out. And the biggest thing we could factor out then would be, well, both 6 and 15 are divisible by 3. And then the biggest, the smallest exponent is the 2, right? So the biggest variable that would divide into both terms would be x squared. And then we kind of set up our parentheses. There's an addition sign there. 3x squared times what gives me the 6x cubed? Well, that'll be 2x. 3x squared times what gives me the 15x squared? Well, that would be 5, right? Then you could redistribute in your head or in your kind of scratch paper or to the side maybe. Redistribute, you get 6x cubed plus 15x squared, and make sure that is the same as that, and it sure is. So then you would be done, okay? Okay, so we just want to do a whole bunch of examples, and hopefully as I do one, you go to the book or to My Math Lab and you try a similar one, and then just rinse and repeat, okay? It's just practice, practice, practice. It's a lot like learning a musical instrument. You just keep doing it over and over and over, and after a while, it's kind of magical after a while because it's anyways. What divides 27, 18, and 45? Well, I think 9. And then the variable with the smallest exponent, x to the first, will divide all 3. And then y to the first is common to all 3. So the leftover bits, 3x y squared minus 2, and then y, and then plus 5x, and that's it. Okay, and I'm going to check it over here. 27 x squared y cubed minus 18 xy squared plus 45 x squared y. Okay, did it work? 7 x squared y cubed. Yeah. Okay. Let's try another. 78. This one is a factor by grouping, and it has multiple variables. xy plus 6x plus 2y plus 12. Okay, so I'm going to group these fellows together, group these fellows together. In the first two terms, I could factor out an x, so you get y plus 6. In the second two terms, I could factor out a 2, and I get that common binomial of y plus 6. Okay, so I'm going to factor out the y plus 6, and I'm left with just the x plus 2, and then that's it. I usually don't check my factor by groupings. Let's see how to do this one. 10x squared minus 12xy plus 35xy minus 42y squared. On the test, they'll be in the same order as they come in the book. So there'll be 6-1 questions first, 6-2, then 6-3, then 6-4, then 6-5. Okay, so my tests are pretty straightforward. I'm not looking for anybody to split the mathematical atom, so to speak. Okay, so I think we can safely factor out, and we want to do grouping again. So in the first two, we can factor out, looks like a 2 and an x. We're left with 5x minus 6y. And the next guys, we could factor out maybe a 7 and a y. We're left with 5x minus, looks like 6 y's. Okay? And then there you see the common binomial. We could factor out of both. So you get 5x minus 6y. And then the leftover parts, 2x plus 7y. Okay. So 6.2 then, we start working with factoring trinomials. Again, the directions you'll see on the test factor. You'll be doing questions similar to 1 to 73 odd. Okay. And let's take a look. Okay. So there's basically 4 forms. X squared plus 13x plus 12. And the way I kind of advise you to do it is to first set up your parentheses, set up your signs. So this has to be plus plus. Put in the variable parts. It has to be xx. And then you're thinking of factoring this into 2 numbers that add to get 13. So 4 and 3. 4 plus 3 is 7. That don't work. 6 and 2. That don't work. 12 and 1 will work, right? So 12 and 1. And then check it to make sure x squared plus x plus 12x plus 1 would be x squared plus 13x plus 1. Whoops, 12 times 1 is 12. And it works. Okay. Okay, so let's look at 12y squared minus, there'll be 25 questions on the test. Okay. All right, so this is going to be minus minus, and we have y and y. There's only one possible factorization for 7. It's 1 and 7. So it's either going to work or it won't. It'll be prime if it doesn't work. I think there's maybe one prime on the test. So if you find yourself saying prime, 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 no, you're making a mistake. I really think there's only one that's actually prime on the test. Okay. Okay. So first, outer, inner, glass, so y squared minus 8y plus 7. Yep. Next, 12, 20. And even, as we go through these, you can pause the video and see if you can get the answer and then unpause it and you can see the answer. That's a good way to practice. Set up your parentheses. And you get plus, minus. Has to be x and x. And then it's either 6, 1, 1, 6, 2, 3, or 3, 2. And we need these things to subtract to give me 5. Okay, so 3 and 2 will give me 1 if you subtract them. 6 and 1, yeah, that's the job. And you want the bigger one to be negative, so you end up with negative 5x. Okay, FOIL it out. Okay, rock and roll. Let's keep going. It's a multivariable version. Okay. What do we have then for 14? And the signs have to be minus minus. This has to be x and x. It's looking, because I need 9, I'm thinking 2 and 7, right? So 2 and 7 squared minus 7x minus 2x plus 14, x squared minus 9x plus 14. Yep, but I need the y as well. So you need to slip a y in there. And then we should be good. So this would be 7xy, 2xy, so 9xy, and then 14y. That should be squared when I multiply them up. Okay. So yeah, checking is a great thing. 3x cubed minus 15x squared plus 18x. So one of the cardinal rules we learned was to always factor out any constants when possible. And here you can see there's a factor of 3 as well as a factor of x. Okay, so what gets left over? We have an x squared, a 5x, and then I believe a 6. Okay, and then we could factor that. And that's be minus minus. 3 and 2. Right, because 3 plus 2 will give me the 5. And sort of FOIL a little bit. X squared minus 2x minus 3x plus 6 is x squared minus 5x plus 6. Yeah. And try to keep your scratch work away from your actual work. Otherwise, it kind of gets cluttered and it's all over the place. And because the problems are just going to get longer and longer over time, you want to have a nice way of kind of separating everything off. Like when you did addition back in school, you would usually do your addition in the margin and that sort of thing. That just kind of quarantines off all the scratch work and makes your work easier to read. Okay. Let's do one more with a leading coefficient that's negative. And generally, if you have a leading coefficient that's negative, you want to factor it out. Okay. If you don't, it kind of looks weird. For example, if I've just factored out the 3, I would have this minus in here. And for some reason, they really hate that because it looks like 3 parentheses minus something. It just doesn't look right. If you do a lot of math, you'll say, ugh, I don't like that. So they want you, just for aesthetics, to pull out the negative with the GCF. Okay. So you'll have x squared, and then I'll change the signs on the inside. It'll flip them all to minus and then plus. This will be 12x, and then this will be 11. Right? So I'm thinking of factoring 11 in a way that adds to 12, so 1 and 11 will probably do the job. So negative 3, we have our parentheses has to be minus minus x, and it's going to be 1 and 11. Let me just check real quick. X squared minus 11x minus x plus 11. It's x squared minus 12x plus 11. Yeah. Okay. Let's move on to 6.3. 6.3, we're factoring trinomials with leading coefficient that is not equal to 1. And I'd be taking problems from the set 1 to 87 odd. I take most of them directly from the book, unless I feel like somebody has a solutions manual and I gotta change it up. But, 5y squared minus 17y plus 6. Okay, so these are more complicated. You still try to fill in what you can, so minus minus is definite. Because it's the same sign, we can kind of fill in the 5y and the y, and then it's just a guessing game, right? So 5y, and then y minus. It looks like 3 and 5 will give me 15, and then plus 2 will give me the 17. So if I put a 3 here and a 2 here, because 6 you could think of as 2 times 3, right? And then the inner guys are going to be 2y, and then the outer guys, negative 2y, and then the outer guys are negative 15y. Negative 15 plus negative 2 is negative 17, so that's going to work. Okay. So minus 2, and then y minus 3. Let's get another one. So one of these, like number 12, we have 3x squared plus 14x minus 5. So this one's a little harder when you have opposite signs going. This will be plus minus, and there's less you can really fill in, right? But anyways, let's come down here and kind of see what we got. So it has to be 3x and x, regardless of the signs. Let's just put plus minus. And that's got to be 1 and 5 or 5 and 1. You only have really 2 choices. If you put the 5 here, you're not going to get a 14 out of it, right? Because it's just going to be 5 plus 3 is 8. So you're going to put the 1 here and then the 5 here. So the first, 3x squared, the outer, minus 15x, the inner, plus x, and then the last, minus 5. The problem with this is that the sign is wrong. You're getting negative 14x in the middle. And we want positive. So the remedy is just to change the signs and make it x plus 5 and then 3x minus 1. Okay, and that should work. Okay, so it would be 3x squared plus 14x minus 5. Yep. Oh boy. Okay, let's look at, maybe skip ahead a little bit. Let's look at 48. And I'll probably, put 5 or 6 of these on the test of this type. This one's a multivariable version, so 3x squared plus 5xy minus 2y squared. Set up your parentheses. It's got to be plus minus, and then we start thinking about all the variations. So it's got to be 3x and x, and then it's either going to be 2y and y or y and 2y. If you do the 2y over here, maybe that'll work. Yeah, so sure, let's try to put the 2y over here and then the y here and see what we get. So we get 3x squared, first the outer minus 6xy, the inner plus xy, and then the last minus 2y squared. So we're off by the sign, right? So we're getting 3x squared minus 5xy minus 2y squared. I need a plus, so again, all you have to do is kind of go 3x minus y, and then x plus 2y, and then make sure it works. Squared minus xy plus 6xy minus 2y squared. And yeah, sure, that works. Okay, 48, 68, 3x cubed plus 14x squared plus 8x. Again, the cardinal rule for these is you're always on the lookout for GCF. And once you identify that, factor it out. So in this case, it looks like it's not even a 3, it's just an x we have to factor out. And so x, and then we get 3x squared plus 14x plus 8. And then our trial and error begins. Okay, so I go plus plus. Ooh, this ain't going to be that hard, right? Because the signs are both the same. We're not going to have to worry about switching the negative with the positive or anything. So we need something to add to 14. So let's see, x and x plus. If I put 8 over here, that's going to be too big. That'll be like 24 for the outer term, so let's not do that. If I put 8 right here and have 1 here, it's going to be 3x plus 8x, which will be 11x. That's not 14. So probably 2 and 4, or 4 and 2. If you put 4 here, so if you put 4 here and then 2 here, you'll have 6 plus 4, which is 10, which won't work. Okay. If you put, seems like I've done everything. If you put the 4 here and then the 2 here, then you're going to get it, right? So you get 3x squared plus 12x plus 2x plus 8. So that'd be 3x squared plus 14x plus 8, and that's it. Okay, so 3x plus 2, and then x plus 4. Okay, so a whole bunch of those. Let's move on to 6.4. In 6.4, we had the special forms, the difference of squares, perfect square trinomials, and the cubics. And we're looking at anything from the set 1 to 95. Sorry, I totally butchered that letter or that number. Okay, so let's take a look. The difference of squares problems are easy to identify because there's only 2 terms. Right? The only issue is maybe you'll confuse it with a cubic type, but the cubics will always have an exponent of 3. So okay. So anyways, the deal with these, hopefully you're familiar more now with the perfect squares. Like 3 squared is 9. So basically, it's always plus minus, and then 3x and 3x, and then 5 and 5, right? And then make sure it works. 9x squared, first the outer minus 15x, the inner plus 15x, last minus 25, those cancel, yeah. 14, x to the fourth minus 25. So, you know, it's not the usual we're used to x squared, but this is x to the fourth. So what times what gives you x to the fourth? It turns out to be x squared times x squared. You're adding exponents. So we'll have x squared here, and then minus 5, and then plus 5. Just a note to the side here, if you have something like x squared plus 5, that's going to be prime. The sum of squares is prime. The difference of squares is okay. We wouldn't necessarily factor this thing, and you could once we get the square roots, but for now we're just going to kind of leave it. And really, we're only factoring when we have nice perfect squares on both ends. Okay? So if this was like x squared minus 16, we could factor it again, but it's x squared minus 5, and 5 is not one of our nice perfect squares, like 16, 25, 36. Okay, let's keep going. 36. So the moral of this problem is to always factor out the GCFs. Factor out a 2, get 16 minus y squared. And then once you factor it, you keep on going, right? So this one looks like 4 and 4, plus minus, and then y and y. And I think that'll work. Okay, so let's try 44. Again, when you have a leading coefficient that's negative, you typically want to factor the negative out with the GCF. So here you could factor out a negative 6 with also a y, and then we end up with 9y squared, and then opposite sign minus 1. Okay, and both of those terms are perfect squares. So we can finish it off by going 3y and 3y. And plus minus, and then square 1 times 1 is 1. So, okay, so those perfect squares, difference of squares. A perfect square trinomial then would be something like number 52. We have x squared plus 24x plus 144. And hopefully you look at that last number and it's kind of maybe a red flag for you, or it's ringing bells to you. 144 is really 12 times 12, right? So you kind of just automatically hope that this is a perfect square trinomial. And, you know, go ahead and FOIL it out, see if it works. X squared plus 12x plus 12x plus 144 is x squared plus 24x plus 144. Yeah, in that case it worked. Okay, generally when I come across these, I'm just doing always trial and error. And my first guess when I'm doing trial error is like this, you know. I'll hope it's just a perfect square trinomial, and a lot of times I'm right, okay, but if not, then you just try something else, trial and error, right? So anyways, x cubed minus 27 for 81, this is a perfect cube trinomial, and we use SOAP with these. Sorry, a perfect cube, a difference of cubes. So the a, we always identify a and b. What times what is x cubed? Well, that's x. What times what is 27? That's 3. And we go same sign, opposite, always positive. Okay, so it's going to be x minus 3, and then x squared. A times b is 3x, and then b squared is 9. Let's do the other version. Well, I guess I didn't incorporate a sum of cubes. Let's try this one though. For this guy, you got to pull out a common factor. And it looks like we could pull out not a 6, I wish. Maybe a 3. No, how about a 2? Yeah. Okay, so I'm left with 27 minus 8y cubed. And it looks like for this guy, what times what is 27? That's 3. What times what is 8? 8y cubed. That one is 2y. Okay, so I can set up my parentheses. same, opposite, always positive. And what do we have? A minus b times a squared plus ab, 6y, plus b squared. 2y squared is 4y squared. Okay, so good stuff. 6.5 is kind of the overview section, and all they do is say, all right, well, here's our general strategy for attacking factoring, and then they just leave you to it. Okay, so the first, most important rule is to factor out any GCFs, and then you kind of base your factoring off the form that's given. So if there's 2 terms, you do this. If there's 3 terms, you do this. If you have 4 terms, it's grouping. Okay, so let's take a look here. Problem 6. We have 64 x cubed minus 1. Okay, 2 terms, it's probably cubic. There's no GCF, so let's identify A and B. So A, it's not 8. What times what is 64? 4x. And then B is 1. So same, opposite, always positive. So I'll have 4x minus 1, and then a squared, 4x times 4x is 16x squared. And then a times b is 4x, and then b squared is 1. And I think that's it. That's all we can do. It's pretty sad. Okay, 24. 7x to the 4th minus 7. So this guy maybe looks like a cubic, but it's not. It's because of that even exponent, it's not going to be. But there is a GCF. You could pull out a 7, and then you get a closer look at it, and it seems like it's a difference of squares, right? Because x squared times x squared is x to the 4th. So let's see if we can factor it. And I'll have x squared plus 1 times x squared minus 1. Always kind of scan when you think you're done. Look at it and say, hey, can I factor this anymore? Because if you don't factor it completely, you're going to lose points. And factoring completely becomes important once we get to working with rational functions. Okay, factoring there, working there requires complete factorization. Okay, so this is important. You're going to use it later in the semester. X squared minus 1 is a difference of squares. That would be x plus 1, x minus 1. Okay. And then you're done. Okay, so don't shortchange me. Okay, so let's look at 26. We got x cubed plus 3x squared minus 25x minus 75. 4 terms, so you better believe it's probably going to be grouping. So let's group these together. The first 2 I can factor out an x squared. The second 2, I'm going to factor out a negative 25. You see I got that common factor of x plus 3 I can factor out. I'm left with x squared minus 25. And am I done? No. X squared minus 25 is a difference of squares again, so we can continue on. You get if you'd rather x minus 5, x plus 5, or x plus 5, x minus 5, either one's correct. So just, again, make sure you keep on going, et cetera, et cetera. Okay, let's look at one that has multiple variables. So, oops, I suddenly got ahead of myself. 3a squared plus 15ab plus 18b squared. Okay, let's say you got a GCF of 3. Then I'm left with a squared plus 5ab plus 6b squared. And then that thing kind of, well, it's not a perfect square trinomial. It has to be a and a. It has to be plus and plus. The only question is factoring this so that adds to 5, right? So 6 and 1 will add the 7. That won't work. 3 and 2, that'll work. Okay. So it's got to be 3 and 2. Let's just make sure that factors correctly or foils correctly. A squared plus 2a plus 3a plus 6 is a squared plus 5a plus 6. And I always catch myself, right? With these, I need the sneak of b in there, right? because I would need 6b squared at the end of the day. 6b squared. And these would be 2ab, 3ab, 5ab. And then it works. Okay, caught myself there. Don't be like me. All right. 6.6 then was applying these to solving equations. So one of the applications, immediate applications for now, will be on solving quadratic equations. I butchered the word solving. Okay, and I'm thinking of questions similar to 99 to 55 odd, and then some story problems probably. I'll probably just put one story problem on there, but stuff like 67 to 73 odd. Probably like physics problems, like you throw the ball up and when does it hit the ground? Those kind of problems. Okay. Okay, so let's dive right in. Take a look. Here we want to solve x squared plus 5x plus 6 is 0. So you solve by factoring, right? So I rewrite the equation, set up my parentheses, it has to be x and x, plus and plus, and then two numbers that multiply the 6 that add the 5. It's 3 and 2, right? And then you can set each part equal to 0. X plus 3 is 0, or x plus 2 is 0. I don't know why I wrote that extra parentheses there. Goodbye. Solve for x, so x is -3 or x is -2. Okay, you circle your answers. There they are. Okay, let's try another 26. 2x squared equals -3x. And this is where I really see if you learned anything, because you remember what I said in the video, what you don't want to do, right? So there's something very bad you could do right here that I don't want you to do. The first step is always setting it equal to 0. I want 2x squared, add the 3x to both sides, and then you want to use factoring to solve. So I can factor out an x, and then you set each term, each factor equal to 0. So there's two factors here. There's the x, and then there's the 2x plus 3. Okay. This first one's already solved, and then move the 3 to the other side, divide both sides by 2, and we have our solutions. Okay, 34. 3x squared equals x plus 4. So again, the first step is to set the thing equal to 0. So I'm going to move the x over, so subtract it from both sides, move the 4 over, and I'll have 0 on the right. Then I need to factor it. So it's got to be plus and minus. And then, maybe have to do a little bit of trial and error. So maybe 3x and x, and then I'm going to go with 4 and 1. Okay, let's see if that works. So 3x squared, first outer, minus 3x inner, plus 4x last, minus 4. And I got the wrong signs, right? So it's got to be x plus 1 and then 3x minus 4. Let me just verify that again. So 3x squared first, outer, minus 4x inner, plus 3x last, minus 4. So 3x squared minus x minus 4. Yep. Okay, then set each part equal to 0. And solve. So x will be -1, subtracting 1 from both sides. Add 4 to both sides here. 3x is 4, divide both sides by 3. Okay, and there's our solutions. Zoop. 46. Let's go. X times 3x plus 8 equals 5, and -5. And you cannot just set x equal 5 or 3x plus 8 equals -5, rather. Okay? You can't just set them equal to -5. The first step is always set the thing equal to 0. Get 0 on one side. Okay, so you got sort of you have to do some backtracking. So first distribute 3x squared plus 8x then move the 5 over to the other side. And then factor this critter. It's got to be plus plus. It's got to be 3x and x. And then if you put the 5 here, that's bad news because then you're going to get 15. And that's way bigger than 8. So it's got to be 1 and then 5. 1 here and then 5 here. Just took my margin here, 3x squared plus first outer 15x. Ooh, yeah, so good thing I checked. Did I say the wrong thing before? So it has to be 5. 5 here and then 1 here. So now let's try it again. 3x squared plus 3x plus 5x. Yeah, plus 5. That'll work then. Okay, set each part equal to 0. So 3x is negative 5, and then x is negative 5/3. Subtract 1 from both sides. X is negative 1. There's our solutions. Okay, so got to get it set equal to 0 first, then factor, then set each part equal to 0. Okay, there shouldn't be any weird division, stuff like that, no. Okay, then some sort of application, right? So let's look at number 67. And and you look it up in the book. I don't have it right now. So uno momento. 67, and this is 6 point something. 6 point something. 6.6. 67. This is on page 480. You got your book, and you're wondering. Okay, 67. On the previous page, they say a ball is thrown straight up from a rooftop that's 300 feet high. Okay, so here's our building. It's 300 feet high, and there's a person that throws a ball straight up, and then it comes right back down. And it's in feet. Okay. The formula h equals negative 16t squared plus 20t plus 300 describes the ball's height above the ground. So h is height above ground. And then t stands for time in seconds after it's thrown. Okay. The ball misses the rooftop on the way down, of course, like I've drawn. So it's going up and then coming back down. The graph of the formula, so I probably won't give you the graph unless you need it. But here we don't really need the graph. So number 67 says, how long will it take for the ball to hit the ground? Use the information. I'm just going to answer the first part. How long does it take for the ball to hit the ground? Okay. And I'm probably not going to do anything with regards to graphing on the test. So kind of not worry. Don't worry. Okay, so when will the ball hit the ground? When does ball hit ground? Okay. What does this really mean in terms of h's and t's? What do we want our h value to be? Well, when the ball hits the ground, the height, h, will be 0. So in other words, we can ask ourselves, when is h equal to 0? Okay? And to answer that question, literally all you have to do then is to take 0 and plop it in here and solve for t, which is the time. So I'll have 0 equals negative 16t squared plus 20t plus 300. Okay. I'm going to, you can either multiply everything, both sides by a negative, or move everything to the other side. I just like dealing with positives better. So I'll move everything to the other side. So add 16t squared to both sides, subtract 20t from both sides, and subtract 300 from both sides. And you'll end up with that. Okay, are there any GCFs I can factor out? Well, looks like you could get a 2. Can you get a 4? Or are we lucky enough to get a 4? I think we can get a 4 as well. Okay, So 4t minus 5, t squared minus 5t minus, and I don't want to screw this up. Seems like I've screwed this up before. So let me go over here. 4 into 30 is 7 times. That's 28. And then 5, 75. Okay. And then I'm going to try to factor that. So, really? Let's be wishful and say this is 4t. We can always rearrange the pluses and minuses. So this isn't set in stone. I may be erasing this. Probably like 25 and 3 is what I'm thinking. But that's not going to work, right? How about 5 and... How many times does 5 go into 75? 1, 5, and... Yeah, that's going to do it. Okay. So if I put a 15 right here... No, I want to put a 5 right here, and then the 15 right here. Okay. And just make sure that works once you get the factorization. 4t is 15, and then t minus 5. So 4t squared, first outer minus 20t inner, plus 15t last, minus 75. 4t squared minus 5t minus, and that worked. Okay. Okay. Set the parts equal to 0. 4 will never be 0, so you're nothing there. Then try 4t plus 15 equals 0. Move the 15 to the other side, so subtracting 15 from both sides. And then divide by 4. Because we're in physical reality, negative times do not really have any meaning for us humans, right? So we're going to disregard that answer. Then go for t minus 5 is 0. Add 5 to both sides. T is 5, and I believe that will be our solution. So then you ask yourself, you know, have I answered the question? And you go back to the question, when does the ball hit the ground? T equals 5. That's great. You want to write it out so another human can interpret your result. Okay. So you can get jobs just doing that, interpreting results, drawing graphs all day long. My aunt used to work for a company and basically drew graphs for them all day long back before they had computers. They have humans do that kind of stuff. Progressive is a big employer of people who find ways to present visual data. Okay. But anyways, the point being here, I don't want just the t equals 5. I want you to write up your answer, interpret your answer. Okay. So the ball, and I'll just take off one point if you don't write out an interpretation. So anyways, the ball, I expect to see a sentence. So the ball will hit the ground after 5 seconds. Okay. Okay, so I need to see some sentence explaining to me that you have some clue as to what's going on here in reality. All right. Okay, so hopefully that makes everything pretty clear, and we all do very well on the first test. So make sure you keep on practicing as much as you possibly can. Get a good grade on that first test. You don't want to get a bad grade and be behind the 8 ball. Not only that, we use all this stuff later in the semester. So if you're really building a castle, you don't want to build the castle on sand, right? Okay, so I'll leave it at that, and thank you for watching, and no video quiz in the review video, and thank you for watching, and I'll see you next time.